Heading into composition of functions. So this is going to be a new topic for all of us. I know I posted the video already, so some of you I know have already looked at this assignment and things. So you'll get some more practice with it today, and hopefully continue to understand it better. But a composition of functions can be presented to us a couple of ways. So as far as our language of math, the first way that we could see a composition of functions is f composed g of x. And in our example problems down here, you'll see a raised open dot, and that's going to mean we're dealing with a composition of functions. And don't worry, we'll talk about how to do a composition of functions here in just a second, but that is one way that you could see a composition of functions. Secondly, it could be presented to us as f of g of x. So where f is one function, and then inside of f is the g function. So here are the parentheses of our f function, and then inside that f function is the g function. Now to complete a composition of functions, what you will do is you will take, in this case, you would take the g's function rule and you would input it into the f's function rule. And that's going to be the process that we're going to go over here in just a second. Is still working with the function rules like yesterday. We'll take the g's function rule and put it into the f's function rule. If the f and g were flipped like they are in our first one, we're going to take the f's function rule and put it into the g function. So down here, this is g composed of f of x. We're going to put the f function rule into the g function. So the next thing that we're going to do is show the process of a composition of functions using g composed f of x, and showing that process of taking function rules and actually putting them into other functions. The first thing I like to do, and in Delta Math they will also present it this way, is rewrite, anytime you have the composition symbol, that raised dot, is just rewrite it as g of f of x. So we're just going to rewrite it like that. And in Delta Math, they're going to be presented like this, g of f of x. So what this is communicating to me is telling me that f of x, its function rule, I'm going to input it into the g function. That's why the f of x is inside those parentheses. It's saying take whatever f of x is and put it into the g function. Now, just like yesterday, we're only working with the function rules. So to put the f of x function into the g of x function, I'm going to show the f of x function rule, which is x squared plus 1. So f of x, its function rule is x squared plus 1. And now I'm showing that the g is going to, x squared plus 1, excuse me, is going to input into the g function. Now, something that you have talked about with functions, if you have like an f of 1, whatever your function rule is, this 1 is the number that you're going to replace in for x. So like if you had a 3x plus 4 or something like that, you would put that 1 in for the x. The thing now with these composition of functions is we're going to take that whole function and we're going to input it into the g function. So the g function is x minus 2. So I'm going to take the f function's function rule, x squared plus 1, and I'm going to input that in for the x in the x minus 2. So I'm going to have x squared plus 1, and what I'm doing is putting that whole rule into parentheses to show that that is all grouped together. That was where the x used to be in the g function rule. Now I've replaced it with the f function rule. From there, you just do anything you can to clean it up and simplify. So the function rule, x squared plus 1, there's nothing else I can do to simplify in those parentheses. So really the parentheses aren't really doing anything. I can take the 1 and the negative 2 and add those together, which is going to give me x squared minus 1. So all I did was just simplify. 1 plus a negative 2 is going to equal negative 1. So I'm going to get x squared minus 1 when I finish my composition of functions. Once you've cleaned everything up and you've got it simplified as much as possible, you are finished with your composition of functions. So that was our g of f of x, taking f of x and then inputting it into the g. I'll take questions here in a second if you have any. I'm going to do the f of g of x next. So we'll do that in a different color too, so it kind of sticks out here. So f of g of x, I'm going to rewrite it. F of g of x. All we're doing is we're flipping around the f and the g. In algebra, you've learned about the commutative property, like when you're multiplying 3 times 4, 4 times 3, they're going to both equal 12. It doesn't matter. With composition of functions, when you flip the order, it is going to give you a different answer. So we're not going to get the same answer of x squared minus 1. We got to figure out our composition of functions going the other way. So what this is telling me to do is take the g function rule, and then we're going to input that into the f function. So I'm going to replace g of x with the g function rule, which is x minus 2. And now I'm going to input it into the f function. So the f function is x squared plus 1. So I'm going to take the x out, and I'm going to input the g function, x minus 2 squared plus 1. So where I put the parentheses and where that x minus 2 is, that's where the x used to be. The x comes out. Now that whole function rule, x minus 2, goes in. X minus 2 squared is actually a FOIL problem, so we have to do x minus 2 times x minus 2, so you will see that again today, plus 1. We'll do our FOIL, x squared minus 4x plus 4 plus 1. And our final answer then, when we simplify, clean everything up, is x squared minus 4x. And then the 1 and the 4 are the only thing that I can combine together, would give me a plus 5. And there would be my composition of functions f of g of x. So you can see definitely they are not going to give you the same exact function as g of f of x. Definitely not going to happen. So every time we have a g of f of x or f of g of x flip the other way, we still need to go through and complete the composition of functions. So at this time, I'll just take a little break. Is there any questions or any clarifications that you need regarding A and B? And we'll be done here in a couple of minutes, so if you want to stick around after and review those problems, that also works as well. All right. I'm going to erase this blue part, so I have a little bit of room to do the next two. The other type of composition of functions we can do is we can actually have a number to input. So the first two we did, we were inputting x into the function, which caused us to just use the function rules. Now we can also input a value. In this case, we're going to input -2, and we can complete a composition of functions as well. Computer is going a little slow here, sorry. It's really thinking right now. There we go. All right, so heading into part C, we're going to go g of f of -2. So again, I'm going to rewrite this as g of f of -2. The only difference now is I do have a number to input for x. So when I'm working with f's function rule, which the one that's inside is the one I'm going to work with first, just like we did above. When I have a number to input into the f function, I am going to do that. So g of f of -2 is going to become g, and then I'm going to input -2 into the function rule for f. And there's what that would look like. So the -2 that's in parentheses, that's where the x used to be in the f function. And there's the f function's rule, x squared plus 1, now with a -2 in it. Once I've got the -2 into the function rule, I can simplify it. -2 squared is 4, plus 1 is going to be 5. So the f function rule is going to give me an output of 5, which now becomes the input for my g function. So I'm going to take that 5, and I'm going to apply it now to the g function. So the g function is x minus 2, which now becomes 5 minus 2. So this 5 that I'm putting in, that's where x used to be. And I'm going to have 5 minus 2, which is going to give me 3. So all in all, after composing -2 into both functions. I get -2 into the f, I get 5. I put 5 into the g, I get 3. So there's going to be my complete composition of functions. Just like above, when we flip it the other direction, f composed of g, we're going to get a different answer. So let's see what we get here. F of g of -2. This is telling me to put -2 into the g function first. So that's going to be f of -2 minus 2. And I should put that into parentheses. I didn't there. But we'll have f of -2 minus 2, because that's what the g function rule is x minus 2. -2 gets put in for x. Now I have f of -4. So all I did was just solve out -2 minus 2, which is -4, and then I can now take that -4 and put it into the f function, which is going to be -4 squared plus 1. And -4 squared, be careful when you're doing negatives to even powers. That's going to be a positive answer. So it's helpful to put parentheses around those numbers when you're raising them to powers. So you for sure tell your calculator that it's the -4 base. And we'll get 16 plus 1, which is 17. So again, you're going to see that when you flip the f and the g around, you will not get the same answer as you did doing it the other way. So our composition of functions, we can go